Good morning, everyone. My name is Festus Temitokbe. I'm a mathematics teacher at the Nigerian Tulip International College. So today I'll be taking us through some of the past questions in mathematics for JAMB. Right. Some of the questions we shall be taking today are questions under indices. In this question, we are to evaluate 81 over 16 raised to the power of minus 1 over 4 times 2 raised to the power minus 1. So to solve this, we express the question in that form. Then after doing that, we express 81 and 16 to their respective bases. So if you put 81 to the base of 3, you have 3 raised to the power 4. And if you express 16 to base 2, you have 2 raised to the power 4. Then raised to the power of minus 1 over 4 times 2 raised to the power minus 1. Now after doing this, the next is to apply this law of indices that says a raised to the power b times c is equal to a raised to the power b times c. So on applying that, we see that this 4, we cancel this 4, and we'll be left with 3 over 2 raised to the power of minus 1, because after 4 cancels 4, we'll be left with what? With 1. And 1 multiplied by minus 1, you get minus 1, times 2 raised to the power minus 1. So on doing this, we also apply another law of indices that says 3 over, that says a over b raised to power minus m is equals to 1 over a over b raised to power m. So which is equal to b over a raised to the power m. So after applying this rule, we get 2 over 3, then times, we also apply the same law of indices, which is the negative index to this, to get 1 over 2. So then we multiply out to get 1 over 3. So our next question is this. In a similar manner, we also express 16 and 18 to a base. So on doing that, we get 2 raised to the power 4 for 16 and 3 raised to the power of 4 for 81, all raised to the power 1 over 4, divided by 9 also to the base of 3 is 3 raised to the power 2, and 16 to the base of 4 is 4 raised to the power 2, all raised to the power of minus 1 over 2. So we can also cancel out some terms after applying the law of indices, as shown earlier, that a times b raised to power c is a raised to power c, b raised to power c, or if it is in form of division, a raised to power a over b raised to the power of c, it is also a raised to power c times b raised to power c. And we also have this if you have a raised to power b times c. This is also equals to a raised to power b times c. So if we apply that law here, we have 4 dividing 4. We also have 2 dividing 2. Then we will now be left with 2 over 3 raised to power 1. Recall that 4 divides 4 to get 1. 1 times 1 gives 1. And also, 2 also cancels 2 to get minus 1. Now, if we apply the law of indices to this, we are going to get this. 3 divided by 4 raised to the power of minus 1, which is equal to 4 over 3. So, on doing that, we get this, because this is negative index law. After applying the law, this becomes 4 over 3. Then we are left with 2 over 3. Then you flip this, then you change this sign to multiplication, 3 over 4. So if you multiply out, the result gives 1 over 2. All right, let us move to the next question. Here we have 27 raised to the power of x plus 2 divided by 9 raised to the power of x plus 1 equals 3 raised to the power of 2x. So one way to solve this is to express 27 to the base of 3. Also, we express 9 as a base 3 number. So after doing this, we also apply the law of indices. Then we get 3 times x, 3x, 3 times 2, 6, divided by 3 raised to the power of 2 times x, 2x, 2 times 1 plus 2, which is equals to 3 raised to the power of 2x. Then after that, we can apply law of indices. Since they all have equal bases, we can apply the law of indices. For division, it becomes subtraction. So we get 3 raised to the power of 3x plus 6 minus 2x minus 2. You may recall that if you have a raised to the power m times a raised to power n, this is equal to a raised to power m plus n. Also, if a raised to power m is multiplied by is divided by a raised to power n, this gives a raised to power m minus n. That is the law we just applied there. Now everything is equal to 3 raised to the power of 2x. Then this implies that since their bases are equal, their power must also be equal. So if we do the necessary addition and subtraction, we get x plus 4 on the right hand side, which is equal to 2x. So let me take you through this, the explanation to this. 3 can easily cancel 3. Then we'll be left with 3x minus 2x plus 6 minus 2 equals to 2x. Then 3x minus 2x gives x. 6 minus 2 gives positive 4 equals to x. So that's it. So we can also collect like terms. So after collecting like terms, we get x equals to 4. Now we move to the next question. So in this question, we are to simplify 3 raised to the power of minus 5n divided by 9 raised to the power of 1 minus n multiplied by 27 raised to the power of n plus 1. So one way to do this is to express each number to base 3. So on doing that, we get 3 raised to power minus 5n divided by 9 as a base 3 number is 3 raised to the power of 2. Then into 1 minus n, and 27 is 3 raised to power 3, then n plus 1. So we can multiply out, we can clear brackets in each power. So to do that, after doing that, we get 2 minus 2n and 3n plus 3. Then we apply the necessary laws of indices. After applying the laws, we know this is division. So it could also be written like this, then multiplied by, we've not changed anything, we only changed the form of division. So then after applying the necessary laws of indices, we get this. Do not forget that whenever we have division, if we apply the law of indices, it changes to minus. And whenever we have multiplication, it changes to addition. So this, after performing the necessary arithmetic operation, we get 3 raised to power minus 5n. You open this bracket, you get minus 2 minus times minus gives plus, then plus 3n plus 3. Then this gives minus 5n plus 2n plus 3n minus 2 plus 3. What I did here is to arrange similar terms, or you call it like terms. So after doing the necessary addition and subtraction, you get minus 5n plus 2n gives minus 3n. Minus 3n plus 3n gives 0. This is equal to 0. Then we are left with 3 raised to power minus 2 plus 3, which is 3 raised to power 1, which is same as 3. So we move to the next question. This question is an indicial equation. So in order to solve this, the first thing we do is to divide both sides by the coefficient of x raised to power minus 2. In this case, it is 8. So on doing that, we get this. Now we can see that 2 goes here, 1, 2 goes in 8, we get 4. Then after doing the necessary multiplication at the denominator, we get 25 times 4, which is 200. Then the numerator becomes 2. All right, let us move to the next question. The next question says we should solve for x if 8x raised to power minus 2 equals 2 divided by 25. To do this, we divide both sides by the coefficient of x raised to power minus 2. In this case, it is 8. So on doing that, after dividing both sides, we get 2 over 25 times 8. Then we multiply the denominator out. If we multiply out, we are going to get x raised to power minus 2 equals to 2 divided by 200. Now we can cancel out because we have common factor here. 2 goes in 2, 1. 2 goes in 200 is 100. Then we can also express 100 as a base 10 number. If we do this, we get 1 divided by 10 raised to power 2. And do not forget a particular law of indices that says a raised to power m minus m equals 1 over a raised to power m. So we can change 1 over 10 raised to power 2 and we can write it as 10 raised to power minus 2. Now after doing this, we see that the terms have equal power. So the powers can cancel out to have x equals to 10. Now we move to the next question. The next question says we should evaluate 27 raised to power 1 over 3 minus 8 raised to power 2 over 3 divided by 16 raised to power 2 over 4 times 2. If you look at this question, one way we solve this is to express 27 to base 3, 8 to base 2, 16 to base 2. So if we do that, we are going to get this. That is, 24 is now expressed as 3 raised to power 3, 8 is expressed as 2 raised to power 3, 16 is expressed as 2 raised to power 4, then we have this. Then some terms can cancel out. 3 will cancel 3. 4 divides 4. 3 divides 3. Then we'll be left with 3 raised to power 1 minus 2 raised to power 2 divided by 2 raised to the power 2 times 2. Yes, because if after cancelling this, 3 divides this, 4 divides 4, we'll be left with, at the numerator, we'll be left with 3 raised to the power 1 minus 2 raised to the power 2 divided by 2 raised to the power 2 times 2, which is what we have here. Now, after doing the necessary, performing the necessary mathematical operation, this becomes 3. Since 3 raised to the power 1 is the same as 3, and 2 raised to the power 2 is 4, then we have this, 3 minus 4 divided by 4 times 2, of which 3 minus 4 is minus 1, and 4 times 2 is 8. Then we move to the next question. The next question says we should simplify 81 raised to the power minus 3 over 4 times 25 raised to the power 1 over 2 times 243 raised to the power 2 over 5. To overcome this question, one way is to express 81 as a base 3 number, 25 as a number in base 5, and 243. We also put it to its what? To its base. Now, 81 is 3 raised to the power 4 if we express it as a base 3 number. 25 is 5 raised to the power 2, and 243 is 3 raised to the power 5. Now here we can see that some terms we cancel out. 4. We cancel 4. 2 will divide 2, and 5 will divide 5. So after doing this, the result is 3 raised to the power minus 3 times 5 raised to the power 1 times 3 raised to the power 2. And clearly we see that after applying the necessary laws of indices, since we have 3 raised to the power minus 3 and 3 raised to the power 2 of this with the same base, we can say this is 3 raised to the power minus 3 plus 2, then times 5 raised to the power 1, which is the same as 5. Then 3 raised to the power minus 3 plus 2 is 3 raised to the power minus 1, then times 5. If you apply law of indices to this, that is a raised to the power minus m is equals to 1 over a raised to the power m. It implies that 3 raised to the power minus 1 is 1 over 3 raised to the power 1, which is still 1 over 3. Then we multiply out, we get 5 over 3. So we move to the next question. The next question, we are solving a simultaneous equation involving indices. Because here we have 2 raised to the power x plus y and equals to 16. And we have another indicial equation, which is 4 raised to the power x minus y equals 1 over 32. Now to solve this is to express 16 as a base 2 number. And also 4 and 32, we also express it as a base 2 number. To do this, we can say 2 raised to the power x plus y is equals to 2 raised to the power 4, because 16 as a base 2 number expressed in base 2 is 2 raised to the power 4. Then after this, 2 can cancel 2. That is, since their bases are equal, their power must also be equal. Then we have x plus y equals 4. You name this equation 1. And we also move to this. We have 2 raised to the power 2 into x minus y equals, if you apply law of indices to this, you have 32 is 2 raised to the power 5. Then this becomes 2 raised to the power 2x minus 2y equals 2 raised to the power minus 5. Remember, in the previous examples, I told you that if you have a raised to power minus m, it is the same as 1 over a raised to power n. That is the law I've just applied. Now here we see that since their bases are equal, their power must also be equal. Then we have two equations that we can solve simultaneously. Now, solving these two equations simultaneously, we see that the value of x is 3 over 4 and y is 13 over 4. Then the next example. The next example, we are also given an initial equation. To solve this, we can see that 25 could be expressed as a base 5 number, same as 125 and 625. So to solve this, 25 in base 5 is 5 raised to power 2, and 125 to base 5 is 5 raised to power minus 3, and 625 as a base 5 number is 5 raised to power 4. So after applying the necessary laws of indices, we get 5 raised to power minus 2 minus 2x times 5 raised to power x plus 2 divided by 5 raised to power minus 3x equals to 5 raised to power minus 4. I think what we should understand here is to multiply out the powers so we can easily remove brackets. Now we can see it is very easy for us to apply the laws of indices, because I also told you in our previous example that if you have a raised to power m times a raised to power n is a raised to power m plus n. Same also applies to a raised to power m divided by a raised to power n, which gives a raised to power m minus n. So on applying these simple or basic laws, we get 5 raised to power, because this is multiplication, you can see we are adding the powers, divided by, this is division, so we decide to leave this for now. Then, if you simplify this, we get 2 plus 2, which is 4, minus 2x plus x minus x, divided by 5 minus 3x equals 5 raised to power minus 4. Then applying the division law of indices, this gives minus into minus 3x to get, because minus times minus gives plus, then 4 minus x plus 3x equals 5 raised to power, which is the same as 5 raised to power 4 plus 2x, because minus x plus 3x gives 4 plus 2x. I beg your pardon, minus x plus 3x gives 2x. So we have 4 plus 2x equals to the right hand side, which is 5 raised to power minus 4. Then since their bases are equal, their power must also be equal. Then 2x is equals to minus 4 minus 4, which is equals to minus 8. Then we divide both sides by 2 to get minus 4. This is what I'm trying to say. You have 4 plus 2x equals minus 4. Then 2x equals to minus 4 minus 4. 2x equals to minus 8. Then we divide both sides by the coefficient of x, which is 2. Then we get minus 4. Now, having done this, we move to the next question, which is likely to be our last question for today because of time. We are to simplify the cube root of 27a raised to power minus 9 over 4, all raised to power 2. Then one way to do this is to express 27 as a base 3 number, as it is shown on the board. We can see here that 27 has been put to base 3 number, which is 3 raised to power 3. Then times a raised to power minus 9 over 4, all raised to power 2. Now, in our previous examples, we solved a question by applying this law. If you have a times b raised to power c, this is equal to a raised to power c times b raised to power c. It also works for division. If you have a over b raised to power c, it is equal to a raised to power c divided by b raised to power c. Yes, you can distribute powers for multiplication and what? And division. But it does not work for addition and subtraction. What I'm trying to say is, if you have a raised to power a plus b raised to power c, this is not equal to a raised to power c plus b raised to power c. It's also the same for subtraction. So, after applying that law, we have these two multiplying 3 raised to power 3, the power of what? Of the base 3 to get 3 times 2. Also times, we also have this multiplying the power of base a. So if you do the necessary arithmetic, I mean you multiply 3 times 2, you get 6. Then here we see that 2. We cancel 4 to get 1 over 2. Then we'll be left with a raised to power minus 9 over 2. Then we also apply another basic law or rule of indices that says the nth root of a raised to power m is equals to a raised to power m over n. You can see the root is now the denominator of the power. So the same is applied here. You can see these 3 coming here. So then we can also apply the same law of indices. Then, if we do that, we get 3 raised to power 6 times 1 over 3 times a raised to power minus 9 over 2 times 1 over 3. Here we see that 3 goes in 3 is 1, in 6 it is 2. And this is 3 here 1, 3 in 9 is 3. So we are left with 3 raised to power 2 times a raised to power minus 3 over 2. Then 3 raised to power 2 is 9. Then a raised to power minus 3 over 2. So if you like, you can say this is 9 times the square root of a raised to power minus 3. So we get this. So that is all for today. We shall continue solving more questions in our next class.